All right, stats fans, we're back. We're going to look at, we've already looked at hypothesis testing, confidence intervals for one samples. Now we're going to move into two samples. Basically, ask the question, is there a difference? So let's jump right into it. We're starting here. Are some groups underrepresented? According to phys.org, Black and Hispanic females are underrepresented in STEM programs compared to non-STEM programs. So STEM is science, technology, engineering, math. A certain university would like to see if this is true for their student population. They took a random sample. There's some keywords here. So we got a random sample of 300 STEM students and found that 12 were Black or Hispanic females. A separate random sample of 500 non-STEM students had 75. So we want to find out, does this data provide convincing evidence that Black and Hispanic females are underrepresented? We're using a 5% significance level. So our parameter here is going to be, we're looking at these two proportions. We have 12 out of 300. We have 75 out of 500. We want to see, is there a difference? What's the actual difference, the true difference in that? So that's what we'll have here. So we're going to start with our P for proportion, and we want to see if when we subtract P1 and we subtract from that P2, and that will be the true difference in proportions of Black. Let me try to make sure we can read that still. And Hispanic females in STEM and non-STEM. So our hypotheses, our null hypothesis for these type of scenarios, H sub 0, will be that P1 minus P2, I'm just going to copy this, that difference in proportions is actually that there is no difference, that it equals 0. And the alternative hypothesis is claimed in the question here. And it wants to know if they are underrepresented. So that when we take the proportion of STEM students that are Black and Hispanic, if that's going to be less than the percentage that is non-STEM. And so because we want, if we took this, the STEM students and subtracted that proportion from, let's say this was 5%, and in non-STEM, in normal non-STEM classes, they were about 10%, then we did 5% minus 10%, that would give us a number less than 0. So that's what we're going to have here, is we're going to have that this is less than 0. We want to make that not down there. So if when we subtract STEM minus non-STEM, if we get a negative value, then that will tell us that they are underrepresented, that there's a lower proportion in the STEM classes. Significance level is told to us it's at 5% or 0.05. That's our alpha level. And then our statistics. So we have two of them here. We have that our STEM is that 12 out of 300, which is 0.04. And our non-STEM is going to be that 75 out of 500, which ends up giving us 0.15. And so what we want to do is we want to take those proportions. So this is going to be our P1. Our first proportion is our STEM. And our non-STEM is going to be our P2. And what we're going to do is we're going to subtract them. There we go. So if I take P1 and I subtract from it P2, I think I still have that there. There we go. And we want to see what that equals. So it'll be 0.04 minus 0.15. That equals a negative 11, negative 0.11. So we already have evidence that our evidence for our alternative hypothesis. So we're going to have a new procedure here. So our new procedure, what we're going to be running is, normally we've been saying one sample. In this case, we have a two sample. Since we're doing proportions, we're going to have a z-test, and we want to test the difference in the proportions. So our difference in proportions, P1 minus P2. These conditions are going to look familiar. We're looking for randomness, and we do see the words random sample for both our STEM and our non-STEM. The university took a random sample. That's good. We want to check our normal. So since we're doing proportions, we're going to do our large counts. And we're going to have to do this 4 times. So we want n times p and n times 1 minus p need to be greater than or equal to 10. So we have that for the STEM and for non-STEM. So we got to do this 4 times. So we'll look at the STEM. STEM was, let's see here, there's 300 people times 0.04%. That gave us 12. This is for the STEM. And when we do the opposite of that, 300 times the remaining 96% should give us a much bigger number, 288. So those are both okay. And for non-STEM, we take that 500 people. There were 15% that were Black or Hispanic females, and that gave us 75. And when we take that 500, multiply it by the remaining 85%, that gives us a larger number, 425. So we are okay to assume that it's normal. And then some of you have been already using and already showing this extra condition that we want to make sure that it is less than 10%. So our sample size needs to be less than 10%, and 300 is less than 1/10 or 10% of all STEM students in the world. And then 500 is also less than 1/10 of all non-STEM students in the world. So that's another condition that we are going to be checking for from here on out. So we got some options. You can go to the calculator, stat, tests. Number 6 is 2-prop z-test. Enter in the data, read the first p-value on the screen. We're going to go try out statlet.com and choose 2-sample z-test for proportion. And I think I need to make a second video for that, so I'll see you in the other video.